Today's video is going to go over how to determine pH and hydronium or hydrogen ion concentration without the use of calculators. On many tests such as the AP Chem test and I believe even the MCAT, you might not have the option to use a calculator. And this is just a quick way to estimate, because we don't necessarily have to have the values to be exact. So we can estimate the range of where our pHs or our hydrogen ion concentration should be, and that will allow us to eliminate obviously wrong answer choices. Now, looking at the box in green, there are a few logs that I think if you take them to memory, it will make doing this process a lot easier. Now let's take a look at this first example of how we can break this down in order to determine the pH of this value. If I have the log of 2.0 times 10 to the negative 8th, I can break that down into two separate logs. So I'm going to have the log of 2.0 plus the log of 10 to the negative 8th. If I refer to my chart on the left hand side, I can see that the log of 2 is 0.3 and the log of 10 to the negative 8th is just whatever the exponent is going to be. And that is just the basic format of how the rest of these are going to work. We're going to simply break it down into its individual parts, and then we can figure out quite easily and quite quickly what our pHs or concentrations should be. The first thing we're going to do is start off by converting these concentrations to pHs. We should already at this point know the equation to do that, so I'm not going to rewrite it out. Now let's take a look at this first one. We have 1.0 times 10 to the negative 9th. Whenever you're dealing with a log of 1, it just makes life easy and it should make us smile. Because whatever the power is, that is going to be our pH. And we just need to make the value positive because it's the negative log of whatever the concentration is. So I'm going to take this value and I'm just going to use whatever that is and make it positive. So this is an easy one. It's just going to be a pH that'll be equal to 9. Now we're going to go to the second one. And this one right here, we're going to have to break it down a little bit. So our pH is going to be equal to the negative log of 2, which we already determined earlier. And if you look on the side, it's going to be 0.3 minus 4. And our pH, once we do the calculation real quick, is going to be 3.7. This next one down here, we would have to do a little bit of estimating because now we are at a 6.4. And if you look up there, we don't have a value for 6. But again, remember, this is about estimation. It's not about being exact because our values are going to be far enough away from each other to where whatever value we get is going to be about the same as whatever is on your as one of your answer choices. So in this case, we're going to do an approximation, and we're going to approximate that to be about, it's going to be somewhere between 0.6 and 0.9, and if we want to, we can estimate it to be about a 0.8. And then again, this 2 is going to come down. And we're going to do our calculation. And we're going to get that the pH is going to be approximately 1.2. If we plug this into our calculator, this is what we're going to get. So as you can see, 1.19, 1.2 is going to be about the same. But again, you might be off by a little bit. You could be at 1.3, 1.1. But again, it's fine because you're only estimating what these pHs are at this point. When you get the opportunity to use a calculator, then you calculate it out. But just for quick, rapid estimation, this is how you do it. Well, at this point, I want you to pause the video, and I want you to attempt these 3 practice problems on the side, and then I will go through them with you momentarily. So our first pH, this one should be relatively easy for you to figure out. We have 4 times 10 to the negative 7. We know what the log of 4 is given to us here on the side, which is 0.6. And we have 10 to the negative 7. So that means that once we subtract our values, we should get a pH of 6.4. This next one will require us to do a little bit of estimation because we have 5.2. So we know that the value that we're going to get is going to be between 6 and 9. If you want to estimate it, round it down to be 0.6, you can do that. Or I would not recommend rounding it up to 0.8 because those values are so far away from each other. What I did was I just rounded my value up a little bit from 0.6 to be 0.7, but if you use 0.6, that's perfectly okay. And we're going to approximate the pH value to be 1.3. And again, if you use if you use 0.6, that's fine as well. Because again, it's about estimation. And this last one, you're going to have to estimate it a little bit as well. And you should have gotten something that would be around 10.4 for your pH. And again, it's about estimating. It does not have to be exact. Let's take a look at the next set. This is going backwards. So now instead of having a pH, instead of having concentration, now we need to get concentration. So we have this first one, which is 8.0. When you're dealing with anything that's something 0.0, those are the easy ones. Those are the ones that you pray that you get, which, because these people in these standardized tests love us so much, they tend to not give us those. So this one's going to be easy. It's going to be 1.0 times 10 to the negative 8th. If we go backwards, we have an x value minus something else. And the only thing that's going to fit here is an 8. The log of 1 is 0. This right here, x would be equal to 0. So the log of, 0 would be the log of 1. I hope I didn't confuse you with that. The log of 1 is equal to 0. X is 0. So then therefore, it has to be the log of 1. Let's go to the next one. Here we have to where we have to figure out what our value is going to be. So if we do negative x plus 3, because this value right here needs to be 1 higher than whatever this value is, if it's not a 0.0. X is going to have to be a number that will help us get to there. So if we were to fill that out, it would have to be 0.7 plus 3. And I'm getting that because it has to be equal to 2.3. So that's going to give us the 0.7 to make them equal on both sides. So if we rewrite this, our concentration will be times 10 to the negative 3 Now we got to deal with this 0.7. So again, this is a little bit of approximation. You could use 4 or you could use 5. It's up to you. So remember, we're at a magnitude of 10 to the negative third. A difference of 0.1 or of 0.000 or 0.001 is not going to make a difference. So it could be either 4 or 5. I came out with 5 times 10 to the negative 3. I think when you put this into your calculator, you might get 4 times 10 to the negative 3. And this last one, pH of 6.7, same process as before. We have a times 10 to the digit that's 1 higher than that, so it should be negative 7. And then now we have to figure out the difference. So our x value is going to be 0.3. Up here, we have a log of 0.3. So it's going to be 2. And if you do your back calculation, you'll see how that's working. So try these examples over here on the side and see how you do. All right, first one should be fairly easy for us because this is a, since this last digit is a 0, it makes this simple. So we're going to have 1 times 10 to the negative 7th. 3.9. We're going to get times 10. And remember, this needs to be 1 digit higher than this one because that 9 is not a 0, to the negative 4th. And the difference is a 0.1. So it's very small. Well, I had to do some major approximation with this because we know that it cannot be 1. It has to be slightly greater, so I approximated it to be about 1.1. Now, again, this one right here was a little bit challenging because if you can go up, because you know it has to be between 1 and 2. But 2 is kind of high at 0.3, so it's just going to be slightly bigger than 1. So that was one that you may have had to play around with a little bit. And this last one, remember, times 10 to the negative 1 higher than this digit. It's going to be to the negative 5th. And we're going to get a difference of 0.9 between 5 and 4.1. So since it's a difference of 0.9, we're going to get 8 for our value. So 8 times 10 to the negative 5th. All right, I hope this was somewhat helpful for you. Again, this is just kind of an introduction and a quick and dirty method for determining the logs, or the pHs and the concentrations of various substances depending upon the information that they give you. Hope this was helpful. If you have any recommendations or if you want me to do it over again, leave a message in the comments.